So I wanted to introduce you to a kind of puzzle called a dissection. A dissection is essentially creating a puzzle that can be one thing in one configuration and another when you switch it around. So, or it could be multiple things when you switch it around. So as an example, this one's a little more complicated than what I'm going to show you later, but I just want to give you an idea of what they look like. So this is one I figured out earlier. It is some kind of cross shape, I guess. I don't know what you call this shape. But after some noodling around, I was able to figure out how to rearrange it so that you can put it together and it is two equal squares like that. So, and then I 3D printed it, so I had a solid piece. So it's got, you need to figure out where to make the cuts so that you can transform it from one piece into the other piece. So does that make sense? That's what a dissection puzzle is. So that's a fairly complicated puzzle there, but I wanted to give an introduction into it, and so I was thinking about, well, what would be the simplest dissection puzzle you could do? So what my challenge here to you is to take a square piece of paper and cut it up in such a way that you can reassemble it into, say, 2 smaller squares, or 3 squares, or 4 squares, or 5 squares. So there's a lot of different ways to do this, but basically the idea is to take one square and cut it in a way that you can take the pieces and rearrange it into a different square or multiple squares. Those are the only requirements for that. You can do it any way you want. So, and I'm using post-it notes here because they're square already and I don't want to spend the time to try to cut squares out of a piece of paper. So these are just a handy way. Also, they're relatively inexpensive and small and pretty easy to cut up. So I've found several ways. Actually, there's probably infinite ways of doing this. If you have a sharp enough scissors and a big enough piece of paper anyway. I'm going to give you one example. This one's probably the most obvious way of doing it, and that is, oh, and by the way, don't worry about making them perfect squares. I don't care. You shouldn't care. You can if you want to. Some people like to be precise, but so probably the most obvious way is to cut it in half, one direction, and then we will cut it in half the other direction. And now we have 4 squares from the one original. So see how many different ways you can figure out how to make squares. You don't have to make them all, but if you have an idea of how to make them, then that's great. Some are more obvious than others. I think you can probably figure them out on your own, but some are non-obvious, like I said. So some of the different ways I found to solve this problem are cutting it into 4 squares that are equal. I found one way to cut it into 2 squares that are equal. There's one way to cut it into 3 squares where 2 are equal but 1 is smaller. And let's see, 4 equal squares. I found a way to cut it into 5 squares that are all equal. I have not been able to figure out how to do 3 equal squares. So I'm just going to keep working on that myself, and maybe later when I film the answers to this, I'll have the solution. But if you can figure it out before me, kudos to you. And I will show you the solutions one at a time. So and maybe you can figure out ways to find your own square dissections that no one else has found before. All right, see you soon. What solutions did you find, honey?
One second, I need to count.
Okay.
I think 6.
Nice. Good work. How many do you think there are possible?
Probably a lot.
Yeah?
Mhm.
Like infinite?
Yeah, probably.
So if you've given it a try and you want a hint, I'm not going to give you the final answer to these, but I'm going to show you how they're cut, and then you can see if you can figure out how to put them together in other squares. So the most obvious one, I think, is to cut the square into 4 pieces, and that way you get 4 squares. You can do this for 2 cuts here and 2 cuts here, and then you'll get 3 squares on one side and 3 squares on the top, which give you a total of 9. You can do the same for 4 and 4, and then you get 16. You can do 5 and 5, and you get 25. See a pattern there? So that's one way, and you can get an infinite amount of solutions from that. The next way is to cut diagonally from one corner to the other. If you do this, you can get 2 squares that are exactly the same size. So I'll let you cut that out and see if you can piece that together. So that's the second solution. Third is to draw a diamond in the center there like that, and then cut out these pieces. And this one actually has 2 solutions. You can either have 2 copies of the center square, or you can have the large square in the center and then 2 small squares. So see if you can find those 2 solutions. Okay, this next one is a little bit not so obvious, and I'm going to let you figure out, if you want, the proportions of this one. So there's a way, if you cut it like this, if you figure out the ratio of these 2 sides here, then it'll be the same from top to bottom. You can find a ratio where, obviously these will always be squares, these 2 on the corner, but if you do it just right, you can actually make a square from this one and this one together. And you're going to have to do a little bit of algebra. In fact, this is related to polynomials here, so it's kind of an interesting one. I'm not going to tell you what the ratio is, but you can find it out if you want. Let's see okay, the next one I'm going to have to just show you here because I am not going to be able to draw this properly. So the idea behind this one, when you're making these squares, one of the things to notice is that the area of these smaller squares needs to add up to the area of the big square. No matter how many squares you're coming up with, that's always going to be true because you're not creating nor destroying paper here. You're just cutting shapes out. So what that means is that the area of these 4 squares adds up to the area of the large square. So 4 times, if you divide the area of the large square by 4, you'll get the area of the smaller square, but then you need to take the square root to find the side lengths, which in this case, I mean, you don't have to really do anything, but if you want some non-obvious, like say square roots, like we were looking at before, we had 1, 4, 9, 16, 25. Those solutions are just done by dividing this up. But if you want say you want 5, then you would take the area of this, divide it by 5, and then take the square root, and that'll give you the length of the squares. So the next step is to make a grid out of those squares, which is what we have here. Each one of these squares, so you want to make a grid out of squares that are the area that you want. So here, each one of these squares is 1/5 the size of a post-it note, the area that we want. So once we create that grid, then we can take, and this isn't always straightforward, but in this case, you can align the center of the large square and the center of one of the smaller squares and rotate it, and you'll find a point where you're rotating this that they all end up lining up, and then you draw these lines here, and if you cut that out, you'll get this puzzle here. So this is the center one here, the whole one, and then you can see all the sides are composed of 2 pieces. So you have a little quadrilateral there and a triangle, and these fit together to make 5 equal squares. Now I thought I could do the same thing to get 3 equal squares. So far we've got two solutions that have 3 squares, but I wanted to find one where all the squares were exactly the same size, the same area, and I haven't figured that out yet. I'm still working on it, but it's been elusive. So I'm not going to give up yet. At some point, maybe I'll just try to, if I can't find it, I might have to try to prove that it's not possible, but I think it is. I don't know. Here's some of the attempts. I've done a few. And anyway, those haven't worked out yet. And hopefully I'm going to leave it to you to figure out how the rest of these fit together. I'm not going to do a solution video for that. So have fun playing around with those puzzles, and if you like these dissection puzzles, we can do other ones like that double cross shape that I showed at the beginning of the video. There's a way to make 1 square out of that, which is the original problem that I was working on, and then I also found one where there was 2 squares you can make out of it, but you can do these out of pretty much any shape you want and turn them into almost any other shape you want. I mean, there's restrictions, obviously. There's sometimes there's actually ones that people haven't figured out yet, so it's still an open problem, and there's a lot of people really into this. I only recently found out about it. I was reading through a book on mathematical recreations and learned about these, and I think they're just totally fascinating because it just takes a piece of paper and pencil and a scissors and some ingenuity and creativity. So I think they're a lot of fun, and I hope you enjoy them too. Thanks. Bye.